Hi, my name is Guy, and I will present you the work we've done comparing different models for pharmacokinetic parameters estimation in dynamic contrast enhanced method. In order to estimate pharmacokinetic parameters in the brain, such as cerebral blood volume, permeability, flow, etc., a model describing the contrast agent concentration over time is needed. A model that has been mostly used since the 90s is the one-compartment extended Tofts model, which is defined by one differential equation and consists of three parameters to estimate. This model does not take blood flow into account. A newer model consisting of a blood flow was proposed for DCE usage at around 2008. This model is defined by two differential equations, leading to a bioexponential solution for the concentration time curve of the contrast agent and requires four parameters to estimate. A more complex model requires better resolution, both temporal and spatial. For example, the two-compartment model usually requires 2-second resolution, while the one-compartment model requires only 6 seconds. Technology advancement allows us to get that resolution and motivates us to use a more complex model. The aim of this work was to compare those two models and show the problem when using a simple one. We did it both by simulation and real data. We synthesized 100,000 concentration time curves using a population average arterial input function filtered through a two-compartment model. We then estimated the one-compartment model parameters and compared them to the parameters being used to synthesize the data. We saw that the one-compartment model might let us estimate permeability when none exists, because it cannot explain the flow effect on the signal. We analyzed the data of a patient with brain tumor. We estimated parameters from both models and compared the result. As expected by simulation, we saw that next to the tumor, we estimated permeability in the simpler model, while estimating high flow and no permeability in the more complex model. When looking on the signal at that area, we can see that indeed it does not have the shape of a signal consisting of permeability. We conclude that when using a simpler model, care should be taken when interpreting permeability maps. The simpler model cannot explain delay and dispersion of the concentration signal caused by blood flow without using permeability. When resolution allows, the two-compartment model should be used, providing a better model and fit to the data. Thank you.